Hey team, welcome into Pushing the Limits this week. I have Elliot Overton to guest, and Elliot is a nutritionist. He's a very, very clever man, and he is an expert in thiamine problems. And thiamine is B1, vitamin B1, and you might think, well, that sounds boring. I can assure you it's not. I want to put this on your radar that there is widespread functional deficiencies of B1, and this can really be impactful for so many disease processes and problems and ailments that you may be dealing with, and you may not know it, and you may have been going from pillar to post trying to work out what the heck's wrong with you, and this could be one of the answers. This is there's a lot of work that's been done in Japan for this for decades. They use it in their hospital systems. There's also Dr. Derek Lonsdale, who has pioneered a lot of the research in this area on thiamine, and Dr. Chandler Mars, who I hope to get on the podcast as well at some point. The reason why this came up on my radar is it's very powerful for neurological conditions, and what we're finding is that a lot of the toxins and heavy metals and there's many reasons why we can have this functional deficiency in vitamin B1, and this is a rate limiting step in the energy production. So this can help people with things like Parkinson's disease, multiple sclerosis, fibromyalgia, traumatic brain injury, gut issues, motility issues, vagal nerve issues, dysautonomias, IBS, IBD, Crohn's, ulcerative colitis. All of these things could be implicated, may or may not, but there has been a lot of research done. Also things like autism, ADHD. This is such a wide range of things that are implicated, because again, it goes back to the cellular energy and the mitochondria and the mitochondrial processes, and alpha-ketoglutarate and the some of the rate limiting steps. So without further ado, because I'll butcher it all, we'll let the expert come to word. If you are wanting to know a bit more, then Elliot has a full guide and a full how to use this clinically. So any clinicians out there wanting to do a deeper dive into this, maybe go and grab the guide off Elliot's website and start to study that. And if you're a client, a patient who's dealing with any of these ailments, I really urge you to pay attention and maybe also go and get this guide. And this is something that's really readily available, not too expensive, and could change your life. So listen up, okay? I hope you enjoy it with Elliot. It is very late where he is and was very early where I am. So hopefully I answered some good questions. Before we head over to the show, please give us a like, rating, review. If you're listening to this on the podcast, or if you're on YouTube, please subscribe to the channel and hit that notification bell, and help support the channel if you're keen. You can go to patron.lisatamati.com or buymeacoffee.com/Lisa T, I think. It'll be in the show notes anyway. Go and have a look. You can buy me a coffee if you like what I do and the work that we're doing here and the team. So thanks very much for that, and go and check out everything over on lisatamati.com with all the programs and resources and supplements and so on that we do. So over to the show now with Elliot Overton. Well, hey everyone, and welcome back to Pushing the Limits. It's wonderful to have you. I have Elliot Overton with me, and I'm very, very pleased to be able to bring you something very, very interesting that's come across my radar. I had never heard of thiamine issue, thiamine B1. This is going to be an interesting podcast, because this has sort of blown my socks off when I came across Elliot's work. So welcome to the show, Elliot. Can you give us a little bit of an introduction to yourself, and what you do and what we're going to be talking about today?
Yeah, thanks for having me on, Lisa. A little bit about myself. I am a nutritional therapist. I trained in the UK. I'm originally from the UK. I run a YouTube channel called EO Nutrition. I own I'm CEO of a supplement company called Objective Nutrients. I am super interested in learning about nutritional biochemistry and the different ways in which different vitamins and different minerals can impact health. I'm interested particularly in an approach called the orthomolecular approach. This is an old-fashioned kind of approach to medicine, using a form of natural medicine whereby you're looking at diseases, various disease processes, and how that involves aberrant changes or problems with metabolism related to certain B vitamins. So it's using natural nutrients to correct imbalances which essentially underpin different diseases. And I think that this can be applied to most, if not any kind of disease. So that's really my interest. But my main focus, and this kind of happened just by chance, my main focus is on one of the B vitamins. This is otherwise known as vitamin B1 or thiamine. I became super interested in that a little bit below 5 years ago, around that time. Started using it in various ways clinically, and found that the results I was getting were nothing short of astonishing. But what was even more amazing was that barely anyone was speaking about this. In the natural health world, like you were saying to me before the show, you will have heard about different B vitamins for different health conditions, and you hear about the longevity molecules, etc. There's lots of information about lots of other types of supplements, but not really much attention is paid to this very simple B vitamin. Ironically, it was the first one discovered. It's been known for over 100 years now, and it has a lot of very useful potential benefits that not really many people know about. So, in short, my main aim was to raise awareness about this and learn as much as I could about it and see how it could be applicable for different people.
Yeah, and you've become the expert, certainly one of the experts in the world, I think, now in this area. And previous to you, some of the work that you've built on is Chandler Mars and Dr. Derek Lonsdale, Dr. Constantini, who's unfortunately no longer with us, and some of their early work, and the work of some of the Japanese scientists and doctors in Japan. They've been studying this for a long time. And what fascinated me, as I said before, is I'd never ever come across thiamine problems as being something that can help things. Like, we're going to dive into everything from fibromyalgia to chronic fatigue to Parkinson's to multiple sclerosis to TBIs to gut issues, IBD. This is something that if you suffer from any of those, you need to pay attention and listen to this, because this could be something that really, really affects you. So we've set the sort of stage now for thiamine, and can you just give us a bit of an overview, a sort of biochemical overview with it, without going too deep into the weeds? When we're exposed to things like, let's go back a bit further. Some people are born with thiamine problems, and the genetic defects, some of the diseases that can come up with genetic defects, and these are sort of usually picked up early on, and the doctors that use high-dose thiamine to save people's lives, basically. Can you talk a little bit about that first, and then go into the toxins and all that sort of stuff later?
Yeah, of course. So, first of all, thiamine, like I said, it was the first B vitamin to be discovered. B vitamins, minerals, the way that the body uses them, I assume that your listeners know this, but just very basics. What we do with them is essentially they are oftentimes used as what are called cofactors for enzymes. So they allow certain processes to occur in our body. We use various different vitamins and minerals in lots of different enzymatic processes. One of the main ways or main things that people learn about if they study basic biology is how our cells convert food into energy, right? So we have glucose, we have fats, we have proteins, and basically what we're doing is we're taking those, breaking them down into very small pieces, and then their constituent molecules need to be processed in certain ways. And to process them, we need to run them through little steps, little tools, little cogs in a machine. You think of it like that. And to get those cogs to go around, those enzymes, we use different nutrients. Okay. So if you don't have nutrients, then those cogs in the wheel, they can no longer turn, and we can no longer effectively do certain things. That's a very basic stuff. So when there are certain people who are born with genetic or inherited defects in their genes. They're stemming from whatever mutations, and basically these are the kind of things that just 100 years ago, if these children would have been born, then they would usually die within the first couple of days, or maybe even the first week, a few weeks or months. And these are called disorders of metabolism. So there is this underlying concept that was discovered, and it was discovered at some point throughout the 20th century, that certain disorders of metabolism could be responsive to high-dose vitamin supplementation. This isn't just relating to B1. This is all of the B vitamins that we know of. They can be used in very specific clinical circumstances, given at super high doses to restore or to restore some kind of balance to someone's system if they have these disorders of metabolism. I'll explain why, just very basic. So an example would be if you have a child which is born with a condition called methylmalonic acidemia. Okay, that's a long word. Basically, what it means is that they are born with a gene defect, which means that they can't effectively process a chemical called methylmalonic acid. Now, the cofactor for the vitamin, the vitamin cofactor that you need to process methylmalonic acid in the body is usually B12. Okay, so what they find is that, okay, if you have someone with a genetic defect where they can't process this, sometimes in certain people, if you give very high amounts of B12, what you can actually do is you can stimulate the way in which that genetically defective enzyme is working. And oftentimes the reason why these genetic conditions operate in the way that they do is because the enzyme that they are given, or the enzyme that their body makes because of the mutation, it can't bind very well to the vitamin cofactor that it needs.
Yep.
So there's a low binding affinity. So basically what doctors and what geneticists and things can do is, in certain circumstances, give high doses to people to be able to essentially restore the function of those enzymes. So this applies across the board. It applies to B6, it applies to biotin, vitamin B1, like we can talk about. So there is this underlying concept that in certain circumstances, if enzymes are not working as they should be for whatever reason, whether that's genetic or what I suspect is whether that is also environmental, pathological, what can happen is that by using high doses, then you can essentially stimulate or reignite those enzymes and have them working again.
So you're sort of flooding them, and the affinity isn't very good, but by giving it so much that it's enough to get the cogs in those wheels going, if you like. And this is really interesting, because then if we take that concept now, and okay, you and I probably weren't born with a genetic defect in any of these areas, otherwise we may not have made it this far, or unless we were lucky enough to have a doctor that picked that up early. But when we're older and when we are exposed to things like heavy metals, toxins, traumatic brain injuries, there's many reasons that this can happen. We can end up with a functional deficiency again in this B1 vitamin. So this is not a nutritional deficiency in the sense of I didn't have enough of my veggies this week and I've now got not enough B1, or whatever the case may be, but more of a functional deficiency, so that there's an enzymatic inhibition. Is that what's happening? So we're not born with a genetic defect necessarily in these cases, but when you say you've got traumatic brain injury is quite an easy one to conceptualize. And I know that there was a couple of rat studies that you mentioned in one of your podcasts that they gave these rats a TBI, but they gave some of the rats high dose thiamine prior to the injury and notice what happened. So this is where we're overcoming the problem by giving high doses of thiamine in these sorts of cases?
Okay. So to understand that, just to backtrack a little bit, basically it's important to for the listeners to understand, I think, is that right. So thiamine, it's really, really, really important for how cells are making energy from glucose. Okay. But also in how we're processing proteins, how we're processing fats for energy. But it's really central to energy. That's one thing that sparked my interest in, I think, is kind of odd why not more information is known about this. But ultimately, thiamine is almost synonymous with energy generation in cells, and this applies across the board in basically all life forms that we know of. Okay, and so we were talking about how certain vitamins or minerals are cofactors for specific enzymes. Well, thiamine is paired or is necessary for certain steps in how we're making energy, and what they're called rate limiting steps. And what this basically means is that there are certain steps or cycles within cycles. And so if your listeners are familiar with the process of energy generation, then there's a step called glycolysis, there's a step called the Krebs cycle, there's a step called the electron transport chain, and they're basically consecutive steps in how we're making the cellular form of energy, ATP. So we take glucose to start off with, end up with ATP, and it has to go through all of these steps. Now, among that, through like connecting those multiple pathways are these rate limiting enzymes. And what that basically means is that when they slow down for whatever reason, and this could be a normal function of how our cells know when to make energy or when not to make energy, when those rate limiting enzymes slow down, then every consecutive step after that also slows down. So give an example, for instance, if you are trying to burn glucose, but one of the enzymes called pyruvate dehydrogenase stops working or is intentionally shut down or inactivated, then you're going to have a slowdown of the consecutive steps, and you're going to make less ATP. So ultimately, these really key enzymes, these rate limiting enzymes, they are super important. Now, sometimes the body will naturally turn them down based on demand. So, for instance, if you're sat down, or if there's certain circumstances, your body might say, okay, we need to turn off this enzyme and turn on this enzyme, or stimulate this or stimulate that, or whatever. So there's this complex regulation which is going on all of the time. However, under certain circumstances, there is what is called like a blockage or pathological blockage on metabolism. So the way that they figured this out is that if you look at research on neurodegenerative conditions, okay, one thing I haven't mentioned is that thiamine is not only important for how all of our cells are generating energy, but it's also really, really got a high affinity for the brain. It's needed for how the nerve cells are essentially communicating messages to one another. Now, when you look at the research on neurodegeneration, what they'll basically do is they'll look at, say, for instance, Parkinson's disease or Alzheimer's or something like that. And what they'll do is they'll take slices, or they'll take sections of the brain which are known to become dysfunctional in those conditions. An example in Parkinson's disease would be the substantia nigra, which is actually responsible for making dopamine. So people who have Parkinson's disease generally have poor dopamine output, and it has to do with this area of the brain, or this collection of cells, which synthesize massive amounts of dopamine. But when they become dysfunctional, when there's damage, when there's inflammation, when there's basically death of the cells in that region, the brain can no longer, you get the phenotype of Parkinson's, you get the symptoms, okay? So what they do is they'll basically take slices out of these regions of the brain, and they'll examine what's going on at the cell level. And what they look at is they see, well, we have this part is working well, this is working well, this is working well. However, what we do see is that there's this problem here and there's this problem here. Now, one of the key issues in neurodegenerative conditions almost across the board is that there is this inhibition of these rate limiting enzymes. So one of those being alpha ketoglutarate dehydrogenase. It's a really big name, but ultimately what your listeners need to know is that this is a thiamine dependent enzyme. Okay. Yep. Now, in many of the papers, and they found this out several decades now, but in many of the papers, what they highlight is that, okay, under certain circumstances, this might be protective in the short term, and there's various reasons for that. We don't need to go into the technical details, but sometimes the brain or the body will intentionally shut off certain processes, and that's actually a way to keep safe. It's a protective mechanism. However, in the long term, when this happens long term, it becomes pathological. What's meant by that is that becomes the thing which is driving or worsening the health condition. So the theory is that there's something, for some reason it's protective to turn down this enzyme, but then eventually when it's chronically turned off, remember, because it's rate limiting, the cells in that region of the brain can no longer make energy. And over time, you end up with progressive cell death in that region. And this also applies to other conditions as well. So lots of brain-based conditions, heart conditions and everything. So the concept is that by using things which can artificially, or let's say, artificially stimulate that enzyme for whatever reason, not just that enzyme, there's lots of other kind of rate limiting factors involved as well, but this is just from a reductionistic perspective. One of the theories behind giving high amounts of B1 in certain conditions like that is that what you're doing is you're essentially flooding cells with massive amounts of this cofactor, and you're stimulating those enzymes when they're previously been inactivated, in a similar way to the concept like we were talking about before. If you have people with a inherited disorder of metabolism, again, it's using high doses to achieve a certain outcome, and it does seem to play out in real life that it appears to work. So you mentioned TBI. Well, what they did several experiments now. One of the effects of TBI, basically what they'll do is they'll artificially stimulate traumatic brain injury in rats or mice or something, and I'd assume it's bashing them on the head. Now the initial inflammation is not usually the thing which causes the brain damage, okay? And that's important to notice, is that it's rarely unless it's very severe, it's rarely the initial bash or the initial trauma which causes the problem. The issue occurs within 24 to 48 to 72 hours after the initial problem. And the reason for that is because what it does is, when you have a trauma, I would imagine it might be similar with something like an aneurysm as well. This is sending a signal to the immune system, and it's the immune cells which basically become turned on. And so you get this neuroinflammation, and oftentimes you can't turn it off. Oh. So it's this state of immune activation in the brain which persists for a long time after TBI or after some kind of a trauma, which is actually what causes the damage. And part of that relates to what the mitochondria. So your listeners, they're probably familiar with mitochondria. Essentially the energies within, or the factories within cells that help us make energy. Now, what they did was, back to this study, they were essentially found that if you gave massive doses of B1 prior to head trauma in the rats, then you could almost preserve brain function. Whereas those who didn't have the high doses of thiamine prior to trauma experienced all of the massive brain damage, massive neuroinflammation, everything like that. And what they looked at why this was, and it came back to the mitochondria, because the mitochondria are pretty important, not only for making energy, but also telling the body when to activate the inflammatory response. So they play this really important role in modulating inflammation. And so they suspected that by giving high doses of B1, this kind of protective drug kind of thing, it's a vitamin, but it turned out to be very protective. What they could do is because the mitochondria could maintain energy production, the inflammatory response was markedly reduced. And cells that have energy or consistent supply of energy are in a much better state to be able to regenerate, to be able to modulate inflammatory response, etc., etc. So ultimately, it came down to this rate limiting enzyme, alpha ketoglutarate dehydrogenase, which is also, ironically, what they found to be messed up in Alzheimer's, in Parkinson's disease, in Huntington's disease, etc., neurodegeneration in general. So there does seem to be this very central role for the rate limiting enzymes of how we're generating energy in mitochondria, and the chronic or progressive diseases, particularly of the nervous system. And there have been some papers which have spoken specifically about thiamine dependent enzymes and how they are somewhat unique in that ultimately it's been described by a Russian scientist. Her name is Victoria Bunik, I believe. She says that these enzymes are basically responsible for systemically regulating metabolism across the body. And it does seem to be the case that this plays out in plants, it plays out in bacteria, it plays out in fungi as well. In that
evolutionary, preserved across all sort of.
It seems that way. It's fascinating. It's been described. So this one vitamin has been described as the universal anti-stress molecule in plants, in plants across the board. Because one of the first things, if you expose a plant to any kind of stressor, so they call it biotic or abiotic stress, so bacterial or non-bacterial or whatever. If you expose a plant to a stressor, one of the first things it will do is actually upregulate or increase the synthesis of thiamine. That's like one of the first things. So it will increase the uptake of thiamine from the environment. It will increase the amount that it makes, and then the amount of enzymes that use thiamine. And that doesn't apply to any of the other vitamins, all right? So that's one of the first things that a plant will do. Same things with bacteria. If you expose it to some kind of a stressor, it will do the same thing. It will start rapidly start synthesizing thiamine. Now, it's interesting in human cells, if you expose, I mean, you think of the prototypical stressor in humans is ultimately a deficiency of oxygen, or hypoxia, we call it. So, oxygen, if you don't have oxygen for like more than a minute, you're dead, okay? Or I say more than a minute. It differs, right? But I mean, you hold your breath for a minute, and you feel how difficult that is, right? Yeah, of course, some people can do. You do Wim Hof method. You could probably do 6 minutes or something like that, even longer. But that was just a hypothetical number, right? But ultimately, you can't go very long without oxygen. That's because every single one of your cells requires oxygen. The reason is because ultimately mitochondria need oxygen. If you don't have oxygen, you can't make energy and you die. So I see a lack of oxygen as like the base level main stressor that any cell could ever come across, right?
Yeah, well, I love
it's a really good right. I mean, that's one of the ways in which hyperbaric is so effective, because you're flooding your entire system with oxygen at pressure, and that's fantastic. That's amazing. It achieves such amazing benefits. But so a good way to think about stress, or a good way to kind of measure or study stress, is by looking at cells in response to low oxygen conditions. And so again, one of the first responses that a human cell will do, one of the first things it will do when it's exposed to low oxygen, is it will rapidly increase. It will basically suck up thiamine from its local environment. So you have these transporters which are located on the membrane of cells, which allow cells to take up B1. And so when a cell is exposed to hypoxia, there's a molecule called hypoxia-inducible factor. When it's exposed to hypoxia, it will rapidly increase the rate of thiamine transporters, suck up thiamine, because thiamine is one of the main ways in which we are utilizing oxygen. So there seems to be this very interesting overall kind of universal function of thiamine as an anti-stress molecule in plants, in bacteria, but also in humans. And therefore a lack of thiamine, this is why I talk so much about thiamine deficiency, a lack of thiamine, if you look at the effects at the cell level of a lack of thiamine, it's equivalent to hypoxia. You get the same changes. You get increase in hypoxia-inducible factor, you get increase in lactate, you get increase in pyruvate, you get a blockage on pyruvate dehydrogenase. There's lots of biochemical changes that occur when a cell is deprived of oxygen. But this is why it's interesting, is that ultimately lack of thiamine or low B1 is almost synonymous with low oxygen, and that appears to be applied across all kingdoms. And so I do think that there's something somewhat special about B1 that's not very well recognized.
And my brain goes, because I've done a lot of work in the metabolic approach to cancer, and when you said hypoxic inducible factor, my brain went, wow, would this be something to explore for the prevention of cancer? Like a lot of people that have any sort of disease process, or not any, but a lot of disease processes like the ones we've just talked about, they're in a hypoxic state. Their mitochondria are not working properly. And this is why hyperbaric is such a good thing, because it delivers oxygen, up to 10 times the amount to those tissues, and compresses the size of the oxygen molecules and can get through. I'm wondering, my brain is just going ping, ping, ping. Would that help with cancer prevention? I don't know that. I'm just hypothesizing an idea here. But let's take a couple of steps back and go, okay, thiamine. So if I have one of these ailments that we've discussed, and we'll put maybe a list. And by the way, Elliot has a wonderful guide that anybody who wants to do a deep dive into this, who wants to try thiamine, therapy for themselves, B1 therapy, needs to buy this guide, which will take you through the protocols. And we'll talk about the paradoxical reaction, which we'll get to in a minute, and will help you understand the process that you might go through, and then what types of thiamine are available, and what one you might be best to take, because there are different forms of thiamine that we can discuss as well. So I'll put the links to that down below, but let's have a look at what are the types of thiamine, and why is there different variants and derivatives of thiamine, and what's the sort of history behind thiamine hydrochloride, the sort of basic stuff, versus TTFD and sulbutamine. How do you say that one? I can't say that one.
Sulbutamine,
thank you. Or all the benfotiamine. Can you walk us through those main 4 variants, really?
Yeah, of course. Okay, so when the Japanese were studying, quick bit of history, ultimately, I said that thiamine was the first B vitamin to be discovered, and that was discovered. It's been known for perhaps several thousand years, actually. I believe it was 2,000 years ago it was documented in Japan, although they didn't really know what it was. It only got its name in like the late 19th, early 20th century. But ultimately, it was known that, it was 19th century, I believe. What was happening in Japan was that you had this kind of class divide, and the class divide, basically the high classes figured out, or they developed the machinery to be able to polish the rice. What polished rice basically means is the difference between brown rice and white rice. So you remove that brown outer husk, or the husk, which ultimately is the hard part, and you just have the white fluffy stuff. Of course, this was seen as a status symbol. This was something that cost money, and so only certain people could do it, and therefore it was kind of became fashionable among the elites and among the higher classes. And what they began to notice was that those individuals who consumed large amounts of white rice, they would develop very strange conditions, strange health conditions. So the main presentation was either going to be the heart and cardiovascular system. So some of these people get swollen legs. They would develop heart abnormalities, blood pressure imbalances. They would develop vascular failure, so the circulation would shut down, and eventually they would die. Or alternatively, it could affect the brain and the peripheral nervous system. So these people would lose the ability to properly move their legs. They would develop neuropathy, tingling, burning hands and feet. If it affected primarily the brain, then it was going to be delusions. It would be ataxia. So they lose the ability to balance. They lose the ability to control their eyes. But really, it can affect lots of different people in lots of different ways. And just very quickly, in the 1940s, it was discovered that ultimately a mild deficiency can persist indefinitely without people developing these conditions. So the full-blown thiamine deficiency is referred to as beriberi, either cardio beriberi or neurological beriberi, or Wernicke encephalopathy. It usually occurs in alcoholics. So most of the time, doctors don't know to look for it unless you are dealing with someone who's severely malnourished or an alcoholic. But ultimately, in some of the earlier studies where they were looking for the effects of a very mild deficiency spread out over a long time, they figured out that actually people can be on these diets, can be on a mildly deficient diet and not develop beriberi, not develop Wernicke encephalopathy for months at a time. But ultimately, they would develop a progressively, like a large list of very common symptoms ranging from fatigue, lethargy, constipation, IBS, acid reflux, insomnia, anxiety, just really run-of-the-mill stuff that like most healthcare practitioners deal with on a daily basis. Almost everyone presents with these symptoms. That's not to say that everyone has B1 deficiency. However, what I would say is that they discovered back in Japan that the people who consumed the white rice would be developing this. So they did a lot of research and they identified that it was ultimately this nutrient that you found in the brown of the rice. So we learned something very important there. First of all, like I said before, thiamine is perhaps the most important B vitamin for metabolizing sugar and glucose and carbohydrate. And what that means is that ultimately your requirement for B1 is proportional to your intake of carbohydrate. And what do we do in the Western world? We have
heaps of carbohydrate.
Precisely. And refined carbohydrate at that. So for instance, white potato, yes, it contains a lot of starch. At the same time, it also contains a fair amount of thiamine. On the other hand, if you eat refined sugar or refined bread or refined whatever that hasn't been fortified, or perhaps it's been fortified with a small amount, chances are your intake of sugar is going to surpass your intake of B1. So this is one of the reasons why thiamine is really pretty common as a deficiency in the Western world because of our intake of refined foods and alcohol. But I digress. Ultimately, you asked about the forms. So the Japanese studying this, they needed to figure out, okay, we've got all of these people with deficiency. How do we ultimately get how do we get high amounts into the human body? And the reason is because when you just isolate the thiamine molecule, what they found is you have to bind it with some kind of a salt, right? Because it's unstable. It's unstable to heat. It's unstable to light, etc. So ultimately, you have to bind it with something that gives it some kind of chemical stability. And what they figured out was, okay, yeah, you can bind it with a hydrochloride or a nitrate or something like that. However, the problem is that when they gave it in a certain amount, for what it's worth, you need about 1 milligram per day to avoid a frank deficiency. Yeah. When they tried to give high amounts to people, for instance, you give 1 milligram to someone who's severely deficient, it doesn't do anything. It doesn't change anything. You need to have to actually give quite a lot. But the problem is that the body has interesting kind of prevention mechanisms for absorbing too much. And there's various possible reasons for why this might be. But basically you have these things called transporters in the intestine. So it means that when you saturate those, you can only absorb a certain amount. So give an example, you give someone 100 milligrams of thiamine, chances are, because of that saturable transport system, they're only going to absorb about 5% of that. Okay. And that wasn't really enough to address these people's very severe deficiency. They were dealing with a health crisis, So what did they ultimately do? Well, they studied this right throughout the 1950s and 60s. What they figured out was that they accidentally came across thiamine found in garlic. It was called allithiamine. They came across it, but what they found was that when they gave people, they took it themselves and they measured the amount of B1 coming out in their urine. They found out that it was just significantly higher than the thiamine that they had been using. So they had this idea that, okay, they studied this molecule and they figured out, okay, when you take thiamine as a molecule and you bind it with something else, you bind it with a different chemical group, then you can increase its bioavailability and uptake into the human body. So that's basically what they did. They found out ways to synthesize various different molecules with lots of interesting properties. And so if you fast forward to today, that's where all of the different types of B1 on the market that you would find are going to be coming from. One of those is called benfotiamine. It's called an S-acyl derivative. Basically, it is developed in a way that it bypasses the transport system. Likewise, you'll find another form, like you mentioned, sorbutamine, that's known among the nootropics community because it's been shown to have very specific effects in the brain. But again, this also bypasses that transport system. And you'll find another form, which is called TTFD. TTFD is very similar to allithiamine. Allithiamine is not sold on the market because it's generally unstable. But you find this form called TTFD. That's the one that they prefer to use in Japan because, again, it also gets a lot into the body. It does bypass that transport system. But what they found through studying is that different forms have different effects for different people. And that, for instance, benfotiamine is just really, really generally effective for the peripheral system. So for the peripheral neuropathy, if you have patients with diabetic neuropathy, any kind of peripheral pain, back pain, anything like that, benfotiamine can be useful for that. On the other hand, if someone is looking to take it as a nootropic, as in improve their focus and cognition and things like that, sorbutamine generally tends to help. And then for the gut conditions, if someone has a problem with their gut, if they have a problem with their brain, if they have any kind of autonomic nervous system imbalance or brain-based condition, they would usually give TTFD for that. So there are lots of different types of B1 and all of them have slightly different properties. They all give B1 to the body, and they all help the body make energy and help the nervous system communicate messages. But at the same time, each one has its own kind of unique benefit that can be used in different conditions.
Yeah, and this is with things like Parkinson's and multiple sclerosis and brain injury, the TTFD seems to be the better one, but there are pros and cons in each one, and I really would encourage people to get the guide from Elliot, because he goes through in detail the pros and cons of each of these types and why you might need to mix them, and then the dosing schedules. And I think that the thing we need to touch on next, because we're a little bit short on time today, and perhaps we can do a part 2 at some point, is the paradoxical reaction. And people need to understand this. If you're going to go, well, this sounds bloody marvelous, I'm going to try this for my condition. And there's no real toxicity to this. There's no real high risk, but there is reactions that can happen when you start this process. And so you advise often going, starting very low dose and then going very carefully higher. And you have some schedules and protocols in your guide. But tell us a little bit about the paradoxical reaction and why this might happen, and how we need to conceptualize this, because if you're working with someone and they start this therapy and then they get worse for a few days and they freak out, then that's unfortunate, because they may have not got to the benefit. We need to understand this paradoxical reaction and what this is.
Yeah. Okay. So early on, when the Japanese started using thiamine in medicinal doses, so whether they'd use thiamine salts or any of the other forms, what they would find is that sometimes sometimes the symptoms during the progression of recovery would change. I'll give you an example. If someone had low stomach acid as a presenting symptom of a thiamine deficiency, and then they took thiamine, it didn't immediately normalize it. In fact, and this differed based on different people. Within the space of a week or 2 weeks or even 3 weeks in some people, what would happen is they might shift from having low stomach acid to having high or excessive stomach acid. So they'd have the symptoms of, originally it would be food not digesting well, sitting in their stomach, to all of a sudden developing severe acid reflux. Okay. On the other hand, someone might find that if they have low blood pressure as a presenting symptom, then when they take thiamine, they might find that it flips and it goes towards high blood pressure. Okay. On the other hand, you might have someone who is fatigued and who has a condition called postural orthostatic tachycardia syndrome, or POTS. You might find that actually when they take B1, they become even more fatigued. And this would occur for a certain amount of time, and we're not exactly sure the reason why. Now, Dr. Derek Lonsdale, he was a pediatrician at Cleveland Clinic. I haven't spoken about him, but he's ultimately the pioneer of B1. He's written several books on it, and he was in contact with the Japanese physicians who were studying these forms. So he's one of the first doctors to actually use this clinically in high doses and write about it in the US. He's actually 99 now, and he's still writing about it. But ultimately, he was the one who coined the paradoxical reaction, the term. He says paradoxical simply because you would think that if you need a nutrient, if the nutrient is going to fix your health, then actually it can cause, like, the fact that it makes you feel worse temporarily, like, that's paradoxical, because you'd think that actually if you need it, you're going to get immediately better. But usually 9 times out of 10, the people who need it the most tend to get worse before they get better. Now, he theorized, because thiamine is so really essential, we've spoken about as essential for the nervous system. If, for instance, you've got symptoms of an imbalance in the nervous system, whether that's a circulation problem or some kind of a neuropathy or some kind of a dizziness or blood pressure imbalance or something like that, then what is ultimately going to happen is that as you begin taking B1, what he theorized at least was that your system starts to come back online. And so essentially what B1 is doing is it's enhancing the way that the brain can send those nervous signals through the nervous system. But as the brain is kind of relearning or reorganizing in the way that it should work, it might send more than it needs to. So for instance, it might fire at certain points and then not fire at other points. And as you have this rebalancing or recalibration, that is reflective of the paradoxical reaction. So that is one of the things that can cause these odd symptoms. What I wonder, one of the things that he's also spoken about is this theory that when you're in a thiamine deficient state, because it's so important for how you're building things up as well, you tend to go towards this state of catabolism. What that basically means is you're breaking things down more than you're building them up. So you're breaking down your muscle tissue. You often find that people who are underweight or anorexic, not necessarily anorexia nervosa, but physiological anorexia. So someone eats a lot, but they physically can't put on weight. It's not a neuropsychiatric condition. Ultimately, what you would find is that they're in this catabolic state. Their body is consistently breaking things down. But when you add the thiamine in, as the cells are shifting from this catabolic towards this anabolic state, this is reflective of needing a certain rest period. So it's like your body goes into a state where you need to rest, you need to relax, you need to give your body a couple of weeks before it can start working as it should do again. And so there's lots of theories. I have my own theories, but I'm not entirely sure whether anyone actually knows. But what does seem to be the case is that the presenting symptom that someone has due to the B1 deficiency oftentimes will go worse or will become the opposite. So if it's low, it might go super high. If it's high, it might go super low. If it's high, it might go even higher before normalizing. If it's low, it might go even lower before normalizing. So there's like 4 patterns. And, a minority of people will take B1, they'll feel great. In fact, many people who aren't classically deficient, they might take B1 for its nootropic properties or to help them feel like they've got more energy. And oftentimes these people don't have any problem with the paradoxical reaction. They can take it in high doses. They feel as though it improves their focus, their energy, their motivation. That's awesome. But for someone who is fitting the very clinical phenotype for a thiamine responsive condition, like you have someone with a classical deficiency or someone with what we were talking about where we think the enzymes might be blocked up. So Parkinson's disease, fibromyalgia, etc., MS, even chronic fatigue syndrome, some of them, then these people generally need to be aware of this because it oftentimes does happen. And general way to mitigate that is the reaction is going to be proportional to the dose that you take. So for an example is that if you give a very high dose, then someone might feel absolutely terrible. But if you start at a very low dose, say like 5 or 10 milligrams, most of the times you'll find in supplements, there'll be anywhere between 50 and 100 milligrams per capsule. For benfotiamine, sometimes it's even higher. So oftentimes you need to go kind of a 10th or a 5th of the capsule and take that and take that. Generally, there's cofactors that we recommend with it. So the minimum is generally a magnesium supplement of any kind and usually a vitamin B complex behind it just to hit all of the bases to support B1. But ultimately, if you're going to be using B1 to start very slowly, start at like a 5th of a capsule, gradually build up every couple of days, build up by a 5th or by a 10th or whatever, until you gradually get to like 50 milligrams. And then if you feel okay at 50 milligrams, then you increase by 1 capsule or 2 capsules. And you progressively build up the doses. I've got loads of YouTube videos about this. I've got, articles and stuff that I've written on it as well. So there's quite a lot of resources online for free. Of course, I do have that guide, but that's really for like practitioners or people who do want to use it for clinical purposes. If they've got a long-term health condition, they want all the details. I think 9 times out of 10 is probably quite straightforward. Don't necessarily need that. I've got a video on my YouTube channel. It's called How to Start High Dose Thiamine, and it goes through like 5 basic steps. And it's like, yeah, okay, you do this, you do this, you do this, and then generally that's enough for people to get started. And then oftentimes what people will find is that they need to gradually increase the dose to such an extent until their symptoms disappear. And that might be that it's only going to address certain symptoms. It might be that it addresses all their symptoms. Really, there's not really many people who've studied this. Like you mentioned, Costantini found that by giving high doses of B1 to Parkinson's patients, which is considered an incurable condition, he found that ultimately they could achieve clinical remission. I have on my YouTube channel a lady who I interviewed who wrote a book on it. Her name is Daphne Bryan, and she has Parkinson's herself. She was diagnosed 7 years ago. She started using B1, and she is basically symptom-free. When she stops the B1, it comes back. And there are like thousands of people online. I've got, like 6,000 people in my Facebook group as well. there's thousands of people who are getting basically into remission as long as they take B1. When they stop, it comes back. So it's not necessarily addressing a deficiency. There's a lot of potential clinical usage for this vitamin that not many people know about, not many people have studied. So ultimately it's a living, it's a living thing. It's constantly growing, people trying it for different conditions and finding out that it actually works. So I would say that deficiency is probably a lot more common than expected. Anyone who's eating a refined diet or diet high in refined carbohydrates is definitely a candidate, someone who's had a diet high in alcohol, but then also people who have any kind of previous traumatic brain injury, previous trauma to the head, to the central nervous system, spinal injuries, anything like that, they're candidates. Anyone with neurodegeneration, they're a candidate. Anyone with what you call a complex condition, so that would be your ME/CFS, fibromyalgia, multiple chemical sensitivity, CIRS, all of these people generally also tend to be candidates for using B1. And like I said before, you look across all animal kingdoms, the plants, human cells, one of the first things that we will do, all of us, is find ways to get more thiamine. That's one of the first initial stages of the cellular stress response. And so I think that there does seem to be something somewhat unique, somewhat universal about B1 as equating to allowing the organism to counteract stress of any kind, and that applies to toxicity and inflammation and everything like that. So yeah.
I think, I mean, there's lots more research to be done and all that stuff. But if you go and look at, like, if you go to your channel, which I highly recommend people go and subscribe to, Elliot, because obviously he's a super brain and just absolutely fascinating to learn from. It's just start looking at some of the comments in some of your videos, like people with, I don't know, autism and things like that, and all of these things. You just start reading them and you're just like, holy crap, this is powerful. This is really changing a whole lot of lives, and you've got to get through this paradoxical reaction situation. And the reason why I'm so fascinated, I've got a mum with, who's had all sorts of brain injuries and traumatic brain injuries and aneurysms and concussions and brain cancer and every other thing known to man. And I know that, she has problems with like motility and vagal nerve, and I think there's something in that as well. So I'm carefully and cautiously implementing this with her. And the Constantini's work was also interesting, that up until the 1500 milligrams, a lot of the people had no response, and then from 1500 to 1800 they just tipped the balance. It was like they suddenly had an overnight, fix the problem sort of thing. And so don't give up too early is another thing, and don't titrate it up and be cautious in your titration of it going up, and try the various types because of the different ways and mechanisms. And I'm actually doing a combination at the moment of TTFD with boom for Thiamine, is to see how I react. I've reacted with a POTS-like response. I have a lot of adrenal issues, too much stress in my life for too many years. And the last week or 2 weeks, I've noticed, when I get up, I'm sort of like this, and I'm like, okay, right, that's probably a paradoxical reaction that's going on. So I'm just bearing with it, and as I sort of titrate this up. But I
maybe consider potassium for that. That's one thing. Maybe consider that. If you get dizzy, yeah. So the dizziness can be a little bit too low potassium or sodium.
That's very interesting, because I've had technique seizures and things before. I tend to have a potassium issue, I think, and being an athlete that sweats a lot.
Right.
That's just reminded me to go and get some more potassium, I think. That might be
see if it helps.
Yeah, and so magnesium, potassium, the other B2, B complex, anything else that you would mention as cofactors that would help support?
Well, I mean, it depends, right? Because it depends on the form that you use. If you use one of the sulfur-based forms, and like, as you know, I've got like 12 hours of content on my, like, I could talk to you about this for forever. Yeah. But I'm trying to keep it as succinct as possible, because I know we're constrained for time.
But molybdenum was one. If you take the
molybdenum, right? Yeah,
the one that's got the sulfur. So if you're a sulfur sensitive person, which I am, so I did buy some molybdenum to go along with us taking this, just to mitigate that type of thing.
As a general rule, it's electrolytes, including magnesium, Okay, there's usually important because if the cells have been deprived of thiamine for so long, basically thiamine, when cells don't have enough energy, also when they don't have enough B1, then they can't retain potassium. Potassium is meant to be inside, sodium is meant to be outside. In the thiamine deficient cell, potassium leaks out and sodium takes its place. So what happens is that as you increase thiamine, then the cells can actually suck up potassium from the environment. That means sucking it up from the blood. And so one of the main signs and symptoms, or one of the main things that will occur, is oftentimes you get a drop in blood potassium. That means less potassium going around the body. Therefore, that can be one of the reasons for people getting things like rapid heart rate, dizziness, etc., excess thirst, ultimately. So usually you need to be replenishing potassium. You need to be giving magnesium if it's tolerated. And generally, like, you can go detailed with the other B vitamins, but ultimately a B complex is usually just suffice. It will just suffice from a very basic standpoint behind it, unless there's some sensitivities and stuff. But yeah, B complex, electrolytes, and magnesium, and that's a pretty solid baseline. And ultimately, what just one more thing, one thing I didn't mention, but this is also another way which it might be helping, is that ultimately what is happening is that when someone is deficient in B1, or when they are under chronic stress, that there is oftentimes, if you look at many different conditions or conditions which respond to B1, even the ones that aren't classically associated with the deficiency, is when there's an imbalance between the sympathetic and the parasympathetic nervous system. Parasympathetic nervous system has to be working through what's called the vagus nerve, like you mentioned. Now, the vagus nerve uses acetylcholine as its main neurotransmitter. You lose the ability to make acetylcholine properly when you have low thiamine. So one of the first things that will happen in animal studies when animals are deficient in B1 is the vagus nerve stops working. And when your vagus nerve stops working, you lose control of the gut. So you develop IBS, IBD, intestinal permeability, any kind of functional gut disorder. You can develop that with ease. You lose the ability to control systemic inflammation, because that's what the vagus nerve does. And you lose the ability to basically shift between or turn down the stress response. So someone ends up in a chronically stressed state. Their system can't counterbalance that because there's not sufficient vagal signaling. They lose the ability to properly digest their food, and then they end up with a state of chronic inflammation because the vagus nerve is essentially responsible for telling the spleen and the cells in the gut to shift towards a more anti-inflammatory profile. So ultimately, when you lose the vagus nerve, you lose everything. So you can do vagus nerve stimulation, all that other kind of stuff, but if someone's low in B1, then that ain't going to fix the problem. On the other hand, even if they're not low in B1, but they have low vagal signaling, they have poor vagus nerve function for whatever reason, taking B1 can potentiate the action of the vagus nerve. So I suspect in some people who aren't deficient, it can also have a relaxing, or let's say pro-parasympathetic function. It's the most important B vitamin, at least for the vagus nerve. I think for the nervous system as a whole, but specifically the vagus nerve, and factoring in how freaking important the vagus nerve is in counteracting a lot of the issues that we come into contact with in our daily lives. It's it's quite fascinating.
It just blew my mind, actually. I mean, because vagal, I mean, so many people are dealing with, motility issues and IBS and IBD and all of those things, and Crohn's and ulcerative colitis and intestinal permeability and adrenal dysfunction, and, from a stressed out lifestyle. I know I am. So all of that's just opened up another bloody Pandora's box for me. I'd like to spend another hour with you. In fact, perhaps when it suits you, we can continue that conversation, because I do think we've touched on the iceberg there, and I'd love to go a bit deeper in that. I do have to go, because I've got a client who actually probably needs B1 when I think about their case. So I'll be looking to that. Thank you so much, Elliot, for your time today. People, please go and visit. Where can they find you on YouTube and on your website?
Just Google EO Nutrition. So EO, my name's Elliot Overton, EO Nutrition. Type it into Twitter, into YouTube. I'm on eonutrition.co.uk. You'll find me there.
Absolutely wonderful, Elliot. Thank you so much for your insights today.
You're welcome. Lovely to meet you. And we could do this again sometime.
Excellent.
I'm late, but that's
No,
okay.
no, it's okay.
I'll cut to the point. I haven't it. Yeah. Go ahead. I'm late, but that's
No,
okay.
no, it's okay.
I'll cut to the point. I haven't it. Yeah. Go ahead.